Hello everybody and welcome back to another CB Show Tunes tutorial. Today we're going to be working on setting up our character. Now I get it, this character is definitely not a piggy. But that's fine because we're not focusing on the art today, we're going to be focusing on the character movement today. And so far, I'm actually super thrilled with the way that this character turned out. The ideal is that we're going to be focusing a lot on designing characters that are fun to play. Not necessarily super realistic. As you can see, we can rotate like super fast, but it just feels really, really good. And that is the point, is that it's not about realism, it's about how fun is it. And that's what our goal is. So, like I said, we're going to be designing a simple character that works. Now, keep in mind that we're going to be progressing a little bit further on this character whenever we set up like the camera rotations and stuff like that. But without further ado, let's get started on this section. Now, to begin with, you're going to need to come over here to your hierarchy and you're going to create a 3D object and find a capsule, and then boom, you got a capsule. We're going to go and reset the position, so just find these three little dots over here. Boom, it's all set up where it needs to be. We need to set the Y position up to 1, and we have it lined up exactly where we want it to be. So what I would do is I would actually disable your mesh renderer because that's not necessary, and it's just, yeah, you know what I mean? So we're going to rename this as a player. You could do that simply up here. Go ahead and give it a tag called tag, and then add a rigid body on this object. Go down to constraints, select freeze rotation on X, Y, and Z. You can change collision detection to continuous dynamic, and that's all we need to do there. From there, you're going to add in a sphere collider, and inside this sphere collider, you're actually going to scroll in a little bit and drop it down to a 0.1. And you can see it right there. We want to make sure it's at its feet, so we're going to go with a -1 on its position. So as you can see, it's just hovering slightly beneath the ground, which is perfect. Now, here's the deal. This sphere is going to be used as a detection script, or detection essentially, not necessarily a script, but detection for interacting with the ground to ensure that we are falling or not falling. So we're going to need to set this as an is trigger, like so. The next thing that you're going to need to do is bring in some sort of character model. And we're just going to paste them in like so. And boom, just like that. Reposition him to where he needs to be. And as you can see, we now have our own separate character, just like so, which is great. But keep in mind that with these characters, if you want to be able to animate them, they need to have some sort of animator on them. We're going to get more into designing this sort of thing, but if you're familiar with setting up like animators and characters, keep in mind that we're going to be utilizing that a lot. We're going to do some sort of tutorial of doing animations and animators whenever we create our own characters, so just keep that in mind for later on. All right, now what we need to do is we're going to create some sort of player animator for this, or player controller essentially. So we're going to right click anywhere inside of your project really, but try to keep it where your character is. Simply right click, go over to create, find animator controller, boom, you got it done. We're going to open up that player animator, and that's what I called it, obviously, whatever. So open up that animator controller, and you could do this by simply double clicking it, or go over to Windows, find animations, select your animator, and then select the object that has the animator on it. Okay? I'm going to go ahead and delete that because we don't, well, no, I'll keep that for now. Okay, so on this right here, you're going to need to come over to the parameters tab, and you're going to add two parameters. One is a float called speed. Make sure these are spelled exactly the way that we have here. And then the other is a trigger, which is called jump. Now this is very, very important. The reason why we're calling jump as a trigger is because we want to be able to activate it whenever we want to activate it, right? While speed is a float because we want to be able to determine if we're idle or if we're moving, right? So that's just the reason why we have that. Now, for our setup inside of the actual animator, you just simply need to right click, go over to create, and then select a from new blend tree. For this blend tree, give it a name. I'm simply going to call it motion for now. Double click that, and as you can see, it automatically assigns the closest float value. If you have not created this parameter, it will create a float value called blend. You'll just need to rename it to speed. Normally it starts off as a blend type of 1D, so we're just going to add 3 different fields here, and this is where you're going to put your animation. So you can keep these locked if you want, or you can customize them if you want, but we're going to keep them locked, and we need to just set up the different types of animations. So for me, I simply needed to find my idle, And then I would just select my idle. We would select our walk here, select our walk, and then we would select our run, just like so. And you would have that set up ready to go. The next thing that you're going to need to do is create a empty right here. So just simply right click, create state empty, and then just rename this to jump, like so. Now these things don't actually have to have anything inside them right now, but this is something that you will need to do to be able to make sure everything runs, okay? So for our transitions, let's actually first start off with the default. So we want this to be our default, so you're simply going to right click this and then make sure that you do set as layer default state. From there, we're going to do a little bit of a bridge, if you will. So from any state, you're going to right click, make transition, and then select your jump state. For this, you're going to select this transition now, and you're going to add a condition, and this condition is going to be your jump parameter, like so. So whenever we activate our jump, we want to be able to call this right here, and it's just going to run, okay? We don't really need to mess with any of the other settings. They're not so important. The next thing that we need to do is right-click on your jump, make transition, and then make it go to locomotion. So from there, just make sure that has exit time is selected and that there are no conditions, which means this is going to run through once, then it's going to return back to locomotion, like so, and everything's good, okay? Let's head back over into our scene view. All right, now, for this, we're going to select our player and we're going to create a script. Now for the script, go over to your assets folder. You're going to create a new folder if you don't have a scripts folder already, and you're going to call that folder scripts. We're going to go inside of there. You're going to create a folder inside of there, and you're going to call this controllers. Inside of that folder, we're going to create a script called player. So right click inside of there, create C# script, and call it player. Do not call it player controller because you will have a world of pain because Unity already has a component called that. So player works just fine. From there, you're just going to simply drag this onto that object, and then we're going to get into the actual programming side. So we're going to double click this right here. And as you can see, we've already filled this out, which is great. Okay, so at the top, we put require component type of Rigidbody. Let me actually show that inside of Visual Studios. I keep forgetting this is not Bandicam, the one that I used to use, which was great, but you know what, it's fine. Anyway, so yeah, what we need to do is we're going to create a require component type of Rigidbody. This allows us to automatically add that component if that component is not on that object already, which if you have been following along, it should be. The next thing that we're going to do is we're going to set up some variables. Now, these variables are quite simple and straightforward. So for our movement, we're going to create a default speed, which is like our walk speed, our sprint speed, which is our run speed, and then our current speed, which this variable we're not going to assign because it's going to be set dynamically, all right? For our rotation, we're going to create a rotation smooth time, and this, of course, is a float. And I set it to a value of 5. This is just what felt good to me. Make sure that you set these to whatever you want it to be. If you want to be able to edit these at runtime inside the editor, just simply add the serialized field there, and it should be fine. But for me, I'm going to keep it all private. Okay. For our jumping, we're going to add a float for jump force. I set that to 8, and of course we have the amount of jumps that we have available. I set that to 2, and then we have our current jumps that we are at. So every single time we jump, we're going to remove one of these jumps that we have available, so we can decide, okay, we could double jump, triple jump, whatever, right? Now keep in mind that if you do set up like your jump force, if we come over here to Unity and we go edit project settings, and let me actually just make sure it's showing inside. Okay, it's not going to show, but go over to your physics tab and you're going to find where gravity is, and just make sure that you change that to a higher value. I found that -23 is the better value, just from personal experience, but it's up to you. It's your game. Make sure that it feels good to you. All right, let's pull this back up. All right, so the next thing that we have is our controls. Now we have a right input and our forward input. This is essentially your X and your Z value. So anytime that we put inputs down for our horizontal and vertical, that's what we're assigning at these points right here. We have two booleans. One is sprinting, one is falling, pretty self-explanatory. we have a float for anim smooth time. This is the amount of time it takes for us to transition between like our walk cycle and a run cycle, or idle and run, things like that. Then, of course, inside of our void start, we need to assign a couple things. So we're going to set our rigid body, so our rigid body variable. I guess we didn't cover that. So create a reference for a rigid body, so call it RB. Reference for our animator, call it anim. Here, we're going to assign it, so we're going to say RB is equal to get component rigid body. And then we need to get the animator off of our child object. So we need to say anim is equal to get component in child or children animator, just like so. Pretty easy to do. We also need to set our defaults. So we're going to say speed is equal to default speed, and our current jumps is equal to our jumps. This allows us to be able to make sure everything is ready to go when we start playing. Now I'm going to press enter a couple times. So we're going to run these things last because technically we need to take a look at some of these other actions first. Okay, so let me close all these things down so then you guys aren't overwhelmed a little bit. And then we'll go through each one. So you're going to, inside of your void update, you're going to add a locomotion script. All right, and this is going to be a function. All right, and inside of this function, we're going to be setting up our movement input. So we're going to say right input is equal to input.getAxis horizontal. Forward input is equal to input.getAxis vertical. I am using the Legacy Edition version of the input system because I personally like it. I think it's better than the newer version, but that's just my personal preference. If you guys want me to do a tutorial on how to run the newer versions, I can do it, but I prefer the older version better, personally. I can't stress that enough, but anyway. So we're going to hard code a little bit for our jumps. So we're going to say if input.getKeyDown keycode.space and current jumps is greater than 1, then we're going to jump, right? And this is another function that we're going to cover. So keep that in mind. Just write it in. It's going to have red squiggly lines. It's fine, okay? Next, we're going to check it for falling. So we're going to say if is falling, we're going to return, which means we're not going to be able to activate our sprint function. Or sprint action. So for us to be able to call if we are sprinting, so setting this Boolean is sprinting, we're going to assign it by having our input down. So we're going to say input.getKey left shift. So as long as our left shift is down, then is sprinting is equal to true. Once we let go of that key, our is sprinting is equal to false. Then we're going to set our speed. So we're going to say speed is equal to is sprinting. And then we're going to say, okay, so if is sprinting is equal to true, so the left side of this colon right here means it's saying, okay, this is true, and then this is false. So if it's true, then we're going to say mathf.lerp, we're going to take our current speed, and then we're going to set our speed to our sprint speed. Our transition time is going to be our animation smooth time multiplied by our time.delta time. The reason why we're using our anim smooth time is because we want to be able to sync our animation speed and our animation transition and our sprinting transition at the same time. So we don't want them to be different, and we don't want to have to play around with the values. So this is just an easy way of doing that. Okay, and we're going to, of course, multiply by time.delta time. If is sprinting is equal to false, so we're going to set our speed, and we're going to do the exact same thing, but we're going to just change our next speed, or the speed we want to go to our default speed instead. All right. So that's all our locomotion. The next thing is our rotation. So to set up our rotation, this is relatively easy to do. We will possibly change this a little later on whenever we set up our camera, but for now, this will work. So we're going to say if our right input is equal to 0 and our forward input is equal to 0, we're going to return, which means that if there's no inputs on our keyboard, we don't want it to do anything. Otherwise, we're going to say create a variable called target rot. We're going to make it equal to our mathf.aton2. And for this, we're going to get our right input and our forward input. So what this is doing is it's getting our x value and our y value, right? And it's saying, okay, so between these two different points, right, what is the distance between them? And then we're going to multiply that by mathf.rad to degree. So it's turning that into a degree. So we're going to say, okay, so the distance between these two is x. So now we're going to turn that into a degree point, and then it's going to rotate towards that individual point. All right. Then we're going to set a rotation. So we're going to say transform.rotation is equal to quaternion.slurp. And now if you know the difference between slurp and lerp, slurp allows us to transition between two different rotations, while lerp allows us to transition between like vectors and floats. Okay, so just keep that in mind. That's the reason why we're using slurp here. So quaternion.slurp, and we're going to take our current position, so transform.rotation, and we're setting our next position, or the position we want to move to. So quaternion.euler, 0 on our x, target rot on our y, and 0 on our z. And then for our time to rotate, we're going to say rotation smooth time. And we can multiply that actually by time.delta time as well, just to sync it with the game. So for our last thing, instead of our update function, we're going to call our animation. So instead of here, this is simply going to get a float for our max speed, and we're going to make it equal to our is sprinting. So we're going to say, okay, if is sprinting is equal to true, we're going to set it to 1. If not, we're going to set it equal to 0.5. So we're using the exact same logic, but this is how we're syncing the two together. And then we're going to call this update animation by axis function and plug in our max speed. Now I know we haven't covered it. We're about to cover it in like a couple seconds. So just bear with the red squiggly lines for just a couple seconds. All right. All right. So now since we covered all the locomotion, let me close that out. Just so I remember, we're going to cover our jump function. Now for our jump function, all you need to do is simply say cur jumps minus minus. So we're going to remove it by 1. Then we're going to say is falling is equal to true, making sure that we are inside the air. We're going to set rigidbody.velocity is equal to a new vector 3. We're going to set that rigid body velocity. So we're going to say our rb.velocity.x because we don't want to move our x position. But we want to change our y position. So we're going to say that is equal to our jump force. And we don't want to change our z position. So we're actually going to change that to z. I don't know why I had that as y. Yeah, so that should fix the problem there. Next, we need to say, okay, so anim.setTrigger jump. So this is where we're calling our jump. So anytime we press that spacebar, it's going to allow us to be able to jump multiple times. For our update animation by axis, this is a very simple script. It seems very complicated, but super simple. So for our condition, we're going to make sure we add in our float called max speed, and then we're going to ask a question. So this is simply asking, okay, are we putting any sort of pressure on our horizontal or vertical inputs, right? So as long as these are equal, or if these are not equal to 0, so if it's equal to greater than or less than 0 on both of them, then we're going to set our float speed. So we're going to say anim.setFloat. We're going to set our speed. Then we're going to lerp between two different points. So we're going to get our current speed value. So anim.getFloat speed. And then we're going to get the speed we want to move to, which is our max speed. Then we're going to set our transition time equal to anim smooth time multiplied by time.delta time. This is the sync, like I told you earlier. Then we're going to ask a question. We're going to say else if. So if our anim.getFloat speed, so we're getting the current speed that our animator's at, is not equal to 0, then we need to set that speed equal to 0. So we're going to do the exact same method. We're going to lerp between two different points. We're going to get the current speed, but the speed we want to move to is 0. So we're going to reset the speed back to nothing. Then we're going to set the transition time exactly the same here. Okay, and then at the way bottom, we're going to take care of our is falling condition. So remember that capsule collider or not capsule, but that sphere collider we talked about earlier? So this is where we're going to mess around with that. So we're going to say on trigger stay. We're going to check if that other .game object is not equal to this game object and is falling. So as long as we're falling and the game object is not equal to the current object that we're touching, then we're going to say cur jumps is equal to jumps and is falling is equal to false. So we're just resetting right there. Pretty self-explanatory. We could use a void on trigger enter, on trigger exit, but I find them less reliable because they're not checking like every other frame essentially. All right, so instead of a fixed update, and this was the one that we didn't cover, we're going to add in our movement for our character. So this is actually where our locomotion is being called. So for this, we're going to create a vector 3 called move force. It's going to be equal to a new vector 3. Our right input is going to be our x-axis, 0 is going to be our y-axis, and our forward input is going to be our, well, forward axis or z-axis. Then we're going to say dot normalize. So this allows us to make sure that we're not dealing with the double speed that most people end up with whenever they're running their character. Like if you hold down the W and D key at the same time, then your character starts taking off and sprinting. We don't want that. So this allows us to be able to hold both keys, and it's going to stay consistent with its speed. Okay? So now we need to assign the speed to this input. So we're going to say move force multiply equal by speed. And then we need to make sure that our rigid body value for our y-axis stays the same or consistent with the rigid body. So if we're jumping, it's not going to make any sort of change. So we're going to say move force.y is equal to rb.velocity.y. And then we're going to set our rigid body. So we're going to say rb.velocity is equal to move force. So this just allows us to run our movement. Simple as that. Okay, so let's head back over into Unity. We're going to take a look at this again. And we're going to have two characters inside of the scene this time. So now, as you can see, they both run. They're both doing exactly what they need to do. And it is awesome. Boom. Well, I hope you guys enjoyed this tutorial. If you did, make sure to leave a like, subscribe, check out some of my other videos. If you have any questions, concerns, whatever, let me know. If you have any sort of videos that you want me to be able to cover, any sort of tutorials, things that are causing you to, get stuck, let me know as well inside the comment section below. I'll be happy to create a video for you guys at any time. All right, guys. I'll see you guys next time. Later.